I was actually born in New York, although my early years I spent in Newark, New Jersey. Um, I'm the oldest of three children, and I kind of ruled my siblings until my next brother turned 13, and then he beat me up, and that was the end. Um, so my father grew up on the Lower East Side. He was totally self-educated. His parents died when he was a child. He lived with other family members. He never went to college. And he always told me that he wished he could have become a chemist, but he didn't. But he loved the outdoors, and he used to take us hiking and bird watching. My mother was different. She was very smart. She graduated from high school when she was about 16, and she made it to college, even though her father didn't think women needed an education. And she loved literature, art, music. She took us to museums and concerts. So I always had this kind of dual direction, science and the arts. But I was going to school in the days of Sputnik, and I think Sputnik had a big effect on public school education. So by the time I got to high school, there were a lot of pretty high-powered science courses, and I took them. And I liked them, except for biology, which was taught very badly, very old-fashioned, and I hated them. But that's what really got me started. And I had a summer job at Albert Einstein working in a mouse lab because my mother gave piano lessons to the daughter of a scientist there. And I wasn't really sure what to do after college. It's kind of hard to really remember how science professions were not really, not that they weren't an option, but they weren't expected of women. And that's the late 60s. But the head of the lab at Albert Einstein at the end of the summer said, "You should go to graduate school. You know, you're good." So I did. And I went to the University of Wisconsin, where she told me to go, and I ended up working on a bacterial virus. But you know, it was the late 60s, and so I had a boyfriend, and I left graduate school with my master's to go with him first to the University of Washington in Seattle, and then to Switzerland, the University of Geneva. And I ended up working for free in the lab because there was a lot going on, and it was pretty interesting. And I had an idea about some of the things they were finding, and the other postdocs laughed at me. They thought I was totally wrong. And so I started doing experiments, and I was right. And it was a very interesting finding, and that wasn't my first paper. I think it was my second, but it was a pretty important paper. And so then I decided I should go back to graduate school. I had a daughter by then, and I was a single mother. And I went to the University of Colorado because I was hoping to continue working on my discovery. And I ended up working on something related to my discovery, and it was a great thesis project. And I mean, I can talk about that later, but my thesis advisor, Larry Gold, who had been a postdoc at Rockefeller, was really great. He was very young, and he couldn't really restrain himself. If he saw any result that I'd gotten, he was there in front of me trying to interpret it before I could even think. So I learned to kind of hide out from him, so I had a chance on my own. And because it was such a good project, I got invited to give a talk at a Gordon conference, which was quite an honor. And afterwards, I got a ride back with a young assistant professor at Rockefeller. because I wanted to come see my parents in New York. And he was very smart, very interesting, and he offered me a postdoc. And although I had a few other invitations to do a postdoc, I decided to come to him, even at the Rockefeller, even though my thesis advisor said, bad idea, don't do it. I thought I knew better. But my thesis advisor was right. And I was miserable in this lab at the Rockefeller because this guy, he not only wanted to look at the data and tell me what it meant, but he wanted to tell me what experiments to do. And I did not enjoy being a cog in somebody else's science. So that's when I got involved with Peter Modell, who was my husband for 40 years. So in those days, so this is now, I don't know, it was about 1977. People still smoked in labs, and I was a smoker, and there was a little smoking area set up in the hall where I would go, and Peter would come by and bum cigarettes from me. And eventually he started telling me what he was doing in his research. And he was collaborating in those days with Günter Blobel, working on protein secretion. And one big question was whether bacteria did protein secretion and had signal sequences and things like that. So because Peter was a biochemist and my background was more genetics and bacterial viruses, he asked me to start thinking about how I would go about isolating mutants that were defective in protein secretion. And that was lots of fun. And so eventually, not after that many months in this lab, I decided I couldn't stand it anymore. And I asked Peter if I could come work in his lab and look for mutants the way I came up with the ideas that I'd come up with. So he was very cautious and made me talk to a few other professors at Rockefeller. Maybe I would prefer to go there. But in the end, he said I could. And I was not too happy because I had gotten a very prestigious postdoctoral fellowship to go to the first lab at Rockefeller. And let me see, where was it? Oh, so I had a Damon Runyon postdoctoral fellowship, and the head of the first lab, well, he wanted to keep the money, and so he got in touch with them to try and apply my fellowship to someone else in his lab. And the net result of that was we both lost the fellowship, and Norton and Peter had to come up with the money to pay me. So it was Norton's lab then, and Peter was, I don't know, an associate professor maybe. And I did my project, and I worked kind of with him. And it was really a golden age at Rockefeller. I remember we used to go every day to the cafeteria in the Tower building and sit at a big table with all these students and postdocs from Günter's lab. And, you know, a lot of things were happening then about the signal sequence, and we had great scientific conversations. Well, we'll see. I'll try. Yeah. Peter was the one who told all the good stories about the old days at Rockefeller, but I'll try. So let's see, Peter. Peter actually was born in Germany before World War II, and he and his parents made it eventually, after a lot of adventures, to the United States. And they got here when he was 9 years old. He didn't speak a word of English. And they sent him to summer camp. And by the time the summer was over, he spoke English. And he grew up, went to school in New York. His father was some kind of financier, was supposedly a genius at finance, and he really wanted Peter to come into the business with him. But Peter liked science, and although he agreed to work for his father for a while, after 3 years he decided that was enough. So he went back to college, took science classes, and got his PhD at Columbia, and then came to Norton because he wanted to do a postdoc with Norton Zinder. And I mean, he told a great story then about his interview with Norton, where they're talking and all of a sudden Norton gets up and says, "I want to get a cup of coffee," and Peter sort of follows him down the hall, and Norton pours himself a cup of coffee and then turns around and leaves. Never offers anything to Peter. But, you know, Norton was a real character. And Peter was an unusual scientist, in my mind. I mean, he was very smart. He never forgot anything. And he had less ego involved in science. He was not really concerned about public recognition or success. And it made him very generous to other people. So he really helped Norton a lot. He helped me a lot. He helped the students. He found jobs for them. And he was just pretty fabulous at making connections. He was famous in the Friday lectures for asking a question of the speaker in a field he might know nothing about, where the speaker would say, "Oh, that's a really good question. I never thought of that." And most people aren't forced to admit that they've never thought of something. But let's see, so yeah, he was very generous, and he also had many, many friends at the university, not only scientists. He was great pals with the guys in the instrument shop, the guys in the maintenance staff, everywhere. In fact, he used to wear maintenance uniform so that he wouldn't get a lot of radioactivity on his street clothes. I stayed a research associate for a long time because Norton was afraid to promote me to assistant professor because that would start a clock, and eventually the clock would run out, and he was a little, like, not so sure about women in science. He had a different model that he grew up with. But at some point, it was in the Baltimore days, while Baltimore was president, the dean of the student program left Rockefeller, and I had been on the admissions committee, and Baltimore invited me to do admissions, to become, you know, an associate dean, I think I was called. And I did that, and somewhere in there, whether it was Peter, Norton, somebody decided it was time to promote me, so I became an assistant professor. By that time, my science had kind of diverged from Peter's, and I was still working, I was working on a different bacterial virus, one that Norton had actually discovered, filamentous phage F1. And I found a lot of pretty interesting things. I was lucky enough to do a lot of fun genetics and look at interactions between the virus and E. coli, which was its host. So I don't know where to go from here exactly.
So it happened that you got your own lab or not?
Well,
you were promoted and
I became an assistant professor, but I stayed in the group. So Rockefeller was still run in this more old-fashioned way, where Norton was the top of the pyramid. Peter and Ken Horiuchi were associate professors. Everybody still worked in the same group, shared students, reagents, machinery, everything. So my subject diverged, and when there were aspects of it that required kind of a biochemical analysis, then Peter would usually get involved. He would do that. I stuck to the genetics. I mean, it was very fluid, so never totally separate. And I mean, eventually I started working on one of these viral proteins that seemed to be necessary for the virus to get out of the bacteria. And from that analysis, we discovered that there were many proteins very similar to my viral protein that existed in bacteria. So, and they were very important in making those bacteria pathogenic. They somehow allowed for all kinds of toxins and damaging enzymes to be secreted outside the cell. And that marked a big change in my research, in that instead of like a dozen people in the world being interested, lots of people were interested. And I was the only one who really had a genetic system for analyzing this protein, and I predicted that it was a channel. And that brought me into some very nice collaborations at Rockefeller. I mean, I collaborated with Sandy Simon, and we sort of shared a student who did actual physiology on my protein, a membrane protein, and showed that, yes, it did function as a channel. And then I collaborated with Seth Darst. They were doing cryo-EM, and this channel that I inferred from the physiology and other data must be very large. I had a postdoc who purified this, and Seth and a postdoc of his got the first structure of one of these channels. They're called secretins now, whether they're from the virus or bacteria. And they're very important in science of bacteria these days. So those collaborations were great fun. And I don't know, I started getting invited to lots of meetings and gave seminars all around. And I mean, Peter was always there, encouraging and participating here and there. So that's my lab. I had students, a couple of postdocs, but it was very shared. Well, I mean, how it was to be in the lab. I have always felt privileged to be able to work at Rockefeller, and also to live so close so that I could come back after dinner and like run a gel or develop a film or do something. It was pretty great. And I mean, I was busy with my daughter. I would like come in the morning, and I would get to see my plates, my films, everything. The science moves very quickly when you work on organisms that, like, their lifetime is over in 20 minutes. So there was always lots of new stuff to absorb. But I had to leave at a particular time, like around 6 o'clock every night. And on the walk home from 66th Street to 63rd Street, I suddenly switched gears, started thinking about what to make for supper, or, you know, my daughter, her homework, whatever it was. But one of the other things that made life very nice, that I enjoyed anyway, was that thinking about science always kind of operated in background mode for me, so that I could be in the shower and suddenly I understood something, or I'd wake up in the morning and something that had been bothering me about an experiment suddenly was clear. And it was always like that, from my student days till I stopped doing experiments. It's a great privilege to be able to do that kind of work. Well, I already told you about it, I think. It was, I mean, it was my main personal way of, personal experience of validating the importance of basic research. So here I was working on, I had something totally obscure. I had diverged from secretion, which was of, important and interesting. I was working on this virus that nobody much cared about, but I still managed to find out something that suddenly was relevant to a lot of different things, infectious disease and all. It's like CRISPR. The people that started working on CRISPR, they just thought it was some oddity, and it has revolutionized biology. Basic science is the way to go.
Basic science.
And that was the other aspect of the golden age of biology. It was very well funded. You didn't have to spend a lot of time writing grants and, begging for money. And I was lucky enough to be doing most of my science in those days. I think it's much harder now. And I think it has a bad effect. People are kind of afraid to do risky things, and they're much more conscious of, they think much more about the translational application because it's so much harder to get research support. Well, science and my daughter first. So my daughter was dead set against doing anything in science because, as she said, it's so boring. You and Peter just talk all this nonsense at the dinner table. Boring. And she said, women in science, they're not glamorous. But she ended up in science. I mean, it turned out to be what she really enjoyed. And she got a PhD, and while she's not doing research, she's more in education. It's kind of nice that that kept going. So Peter and I did like to travel a lot, but we did some of it all along, like on school vacations, a little bit here and a little bit there. But I mean, we were pretty involved in research and not willing to go away for long. I wasn't willing to go away for long periods of time. But we retired at a good age for Peter, and I was a little young. But I just felt like there needed to be time for other things in life before Peter just wasn't going to be able to do it. And that's when we really started traveling, and we had lots of exotic nature travel. One of our trips was to Tanzania and then on to Madagascar, and that was an amazing trip. And that was early after retirement, and it was a little hard for me to get used to not having a new result to look at every morning. And I was kind of looking around for something else to do. And so I started writing about this trip to Madagascar. And I used to read the travel section in the New York Times and thought, oh, that would be great to publish it there. And at some point, like Jeff Ravitch, who's a professor here now, had been in a graduate student with Norton Zinder and had worked with Peter, and we stayed friends with him. And he told me he had a cousin who wrote for magazines, and that cousin edited my article, my essay, and I submitted it to the Times, and they accepted it. So in a way, that's my favorite publication. And people wrote a lot of letters about it. They liked it, and they liked the photographs that were included too. Peter had taken most of them, and we got calls, not a lot, asking if the person could buy one of Peter's photographs, so that was a lot of fun. And then I kind of eased into retirement, so I kind of came back to the other half of my early interests and got more interested in the arts. And so I go to galleries, I go to museums, I go to the theater. I still come to Rockefeller seminars and try to keep up on the amazing things that seem to be happening, like monthly.
What about bird watching?
Oh, bird watching, yes.
Your father was a...
My father had been a bird watcher, and one of my brothers liked birds, and Peter and I have a house upstate, and we used to watch birds there and travel for bird watching. And in Central Park. So I have lots of opportunities for that, and I'm still enjoying that. I had a great trip in the fall to southeastern Brazil, and I saw some great mammals. I mean, ocelots and jaguars and anteaters, but the birds were fabulous. I like that.
Okay.
Well, one of my strongest memories isn't really a science memory, but it was David Rockefeller's, I don't know, 75th or 80th birthday, and Rockefeller threw this big dinner party for him, actually in the Tower building in the cafeteria that we attended. And I was just blown away by the fact that he talked about his childhood and how when his family would go to exotic countries, they would bring some Rockefeller faculty with them, because in those days, the faculty were all MDs. So they would have medical attention on hand if needed. I just thought that was pretty funny. I think I think it's definitely true that that women had better chance of a career in medicine than they did in research science. Oh, I can tell you one story. It did not happen to me, but I could tell you a couple of stories about what it was like for women in science. Like Marge McCarty told me that when she was going to school at Hunter College and she was interested in chemistry and told her professor, he said, "I can't support that. If you go ahead and apply to graduate school, I will not write you a good recommendation. I don't think women belong in science." That was one. Another one was Mickey Rifkin, who actually was the dean for admissions before me, who and had been a Rockefeller graduate student. And in applying for postdoctoral fellowships, she had to get a physical exam. And part of the physical was to have a chest x-ray. And she declined to have the chest x-ray because she was pregnant. And they took the fellowship away from her. I mean, yeah, things were a little different then. Well, for sure, the microbe hunters was an early influence. A lot of people have the same early book. But one of the others that I really loved is called Phage and the Origins of Molecular Biology. It's a Cold Spring Harbor book. And there are all these essays written by people who were working on bacterial viruses in those days. Everybody worked on bacterial viruses. And they just told these wonderful stories about, I mean, at one point at Caltech, they were working in shifts because the results come so quickly. One person would do the experiment and plate, make the agar dishes and put the experiment on it, put it in the incubator. Somebody else would come in and look at the results from the day before's experiment and plan that. Then the third guy would come in for his shift and see the results of the earlier experiment, and they just kept it going round the clock. I thought that was pretty great. Well, one of the fun things about having been here so long is that I remember hearing thesis talks by Jeff Ravitch, who was in our lab, Michelle Nussenzweig, who's a professor here, his wife, Svetlana Moisev, who's a professor here, and I'm sure there are others that I'm not thinking of right now. And and then there were the students that I accepted who did very well. Some of them came to Rockefeller, went all over the world. That was very rewarding for me. I was never much of a salesperson, but I do remember getting a call from someone who'd applied to the PhD program who said to me, "I've been accepted at Harvard, Stanford, and Rockefeller. What should I do?" And how I somehow managed to not argue for Rockefeller, but to present it in a way that he came to Rockefeller. And
who was that?
Adrian, I can't remember his last name. He had done undergraduate research on snail shells and whether they twisted to the left or to the right. Lots of interactions with Günter Blobel because he and Peter did all this work together. And there are signal sequences in bacteria, and proteins are secreted. And Günter used to invite us to Barbetta for dinner, and that was always fun because the staff at the restaurant, which was owned by his wife Laura, they practically bowed to Günter as he strode in. He was such a dramatic person. And we would come with our daughter sometimes, and Günter was extremely nice to her, would show her around, and those were nice days. And I interacted a fair amount with Ralph Steinman, who was such a lovely guy, and who once, in the course of my promotion, privately told me that he had seen a lot of my letters of recommendation and that they were very, very good. So it was very nice of him to tell me that. I didn't interact as much with the neuroscientists, but I did get to know a lot of people over the years.
Me too.
Yeah.
It happens when you stay at the Rockefeller.
Yeah, that's a great thing about it. I mean, the carpenter, the electrician, the refrigerator guy, they all get to be friends over time.
Absolutely, I agree with you. Custodial people. Yeah.
Oh, yes, Isaiah. I mean, Peter used to have a Polaroid camera in the lab. And I told you about this. He would take pictures of all lab visitors and all the lab members at parties and this and that. And we have quite a few pictures of Isaiah, who used to come by to pick up the radioactive waste, and, and who in the springtime before Easter, because he was always wearing one of these Tyvek protective suits, he would put a little bunny tail on the back of his suit. and entertain us.